Welcome back to Maths with Mrs. J. I know it's been a while. I've been extremely busy this year with all my tutoring. Well done to all my students. I thought it was time for us to do another challenge, and loving algebra the way I do, when I saw this question, I thought this would make an excellent example as a challenge question. Bit of the old algebraic gymnastics is good for us from time to time. It hones our skills, makes sure that we do know what we're doing and we understand the processes involved. Here, of course, we have an equation where we're asked to solve for x, and we do notice that we've got a, b, and c involved as well, rather than numbers. So our answer is going to be an expression involving a, b, and c rather than an actual numerical answer. When we have an equation such as this, where we have rational expressions, we don't like having the denominators there. We don't like dealing with fractions. So the best thing to do is to get rid of the fact that we have fractions involved. You have two options here. What some people will do is they will write both sides with lowest common denominator, and then they'll either cross multiply or multiply everything by the new denominator. I find it easier, and it's an equivalent thing to do anyway, to just multiply every single term by the lowest common multiple of all of your denominators. Because these three denominators are just three linear expressions, we can't factorize them, simplify in any way. So we are going to need all three of those as factors to make our lowest common multiple. So what I'm going to do is, you can see I've set it up here with spaces ready. I am going to multiply every single one of these three terms by those three bracketed expressions. Let's just get that ready. All right, so I've got it in another color just to make it a little bit easier for us. So we need x plus ax minus bx plus c times every single one of those terms. I am also going to put brackets around the bottom expression so that and even around the top here, because we have a sum of a plus b. The reason we've done that is so that then we will be able to cancel, and then we'll no longer have any denominators that we need to worry about. When we do our cancelling, what we're going to have here is this x plus a will obviously cancel out, this x minus b will cancel out, and the x plus c will cancel out. Excuse me. Now what we're left with is, here we've got a times x minus b times x plus c, b times x plus a times x plus c, and here we have three brackets that we're going to need to expand. Exactly how you write that is up to you. Probably is a good idea to do an extra step here where you just write down what you're dealing with. So we've got this equals your x plus a, x minus b, a plus b. Generally, look, it doesn't really matter which order you do your expansion here. I tend to expand my brackets and then bring in my a in this case. You could bring the a into the first or the second bracket and then do a FOIL situation. It really doesn't matter. Multiplication is both commutative, in other words, it doesn't matter which order you do it in, and associative in the sense that it doesn't matter whether we do the a times that and then multiply by that, or do the a times that and then multiply by that, or multiply those two together and then multiply by the a. It doesn't really matter. So I'm going to multiply through here. We're going to get, using our FOIL, x squared plus cx minus bx minus bc. And then we've got here x squared plus cx plus ax plus ac. And then here, look, it doesn't really matter. I'd be inclined to maybe multiply out those two and put the a plus b out the front. So we're going to get x squared minus bx plus ax minus ab. All right, we're going to need to do one more round of expansion. You could simplify these x expressions here, but look, a lot of it's going to cancel out anyway, so I probably wouldn't bother at this stage doing anything with that. So we're going to get ax squared plus acx minus abx minus abc plus bx squared plus bcx plus abx plus abc equals, here we're going to get 8 terms. So ax squared minus abx plus a squared x minus a squared b plus bx squared minus b squared x plus abx minus ab squared. You'll probably notice I generally try to keep my pronumerals in alphabetical order. It makes it easier then when we go back and try to simplify. We can sort of find things that are equal a little bit easier. Let's have a look here what we've got. Well, for starters, on both sides, we've got an ax squared, so they can go. On both sides, we've got a bx squared, so they can also go. What else do we have? Well, we've got, okay, here we've got a minus ABC plus an ABC. Here we've got a minus ABX plus an ABX, so that's going to go. So on our left-hand side, we've just got an ACX plus a BCX. All right, so let's maybe tidy that up a little bit. So X outside of AC plus BC, or even we could write that as perhaps, we'll leave it as it is for now, that's fine. So here, let's get, collect our terms. We have no x squared terms left. So we're just left with x terms and I guess you could say constant terms. These don't involve any x's. These would just be numbers. So with our x's, we've got here a squared minus b squared. So that's those two, a squared minus b squared. So we've dealt with those. Then we've got minus, oh, okay, well, the minus AB and the plus AB, they go as well. I forgot about that before, so that's all good. And then we've just got with our constants, as I said, plus our, minus our A squared B minus our AB squared. Okay, all right. If I'm wanting to get an expression for X, what we really want to do is get all our X's on one side and all our numbers, in inverted commas, on the other side. So these two terms, they're both negative. I would be inclined to pop them over here, so add them to both sides. So we're going to get a squared b plus ab squared equals x. And then I'm going to take away these over here. So I've got a squared minus b squared minus ac minus bc. I've got to do a minus because I'm taking away those terms from both sides. All right, let's see what we're going to get here. We want to try and simplify this as much as we possibly can. On the left-hand side, we can get an AB as our common factor, and we're going to get A plus B. On our right-hand side, let's just take this to the side for a minute. Let's just make a little bit of space over here and fiddle with this expression a little bit. So this expression here, we've got a squared minus b squared minus ac minus bc. One of the skills that you learn in factorising is grouping. Quite often when you're grouping, you will group 2 and 2. And usually if you're grouping 2 and 2, that will involve taking out a common factor of both. In this case, it's going to be a little bit more exciting than that, because when we factorise these first two terms, that's actually a difference of 2 squares. So here we're going to get a plus b, a minus b. And then here we can absolutely take out a negative c and we get a plus b. Now look what happens. We've got a plus b as a common factor. That can come out the front. And we're going to be left with a minus b minus c in our second bracket. So this here on the right-hand side, just coming back over to here, we're going to get x times a plus b times a minus b minus c. All right, you'll notice you've got an a plus b on both sides, assuming that a is not negative b. All right, assuming that that a plus b expression is not 0. We can cancel that out, all right? It's the same expression on both sides. We can divide both sides by that, assuming that A is not equal to negative B. So for our final answer, literally all we need to do, we want to get the x on its own. We are going to divide both sides by this bracket, and we're going to get that x equals AB over A minus B minus C. And there you have it, a little bit of algebraic gymnastics for you. I hope you enjoyed it.